Math 103, Chapter 3. The first set of the homework that you see on Chapter 3 is about the dot plot. We kind of discussed the dot plot in Chapter 2 as well. The method of dot plot is, like in this example, you just go ahead and have all the numbers on the scale. So what is a dot plot and when to use it? Draw a horizontal line, mark it with appropriate numerical scale. Okay, so it's like, let's assume that every unit is just 1 inch or 1 centimeter. So you want to make sure that they all are kind of equal. Locate each value in the data set along the scale and represented by a dot. If there are 2 or more observing with the same value, stack the data vertically. So here, for instance, here, 1.5. So the first one is 1.8. So let's say 1.8 is here. And this is 1.8. Then it's 5.8. You just go to 5.8 and you put 1. And I see there is another one, 5.7. So 5.7 also is a little bit close to that. So you plot all these numbers on the scale. And what are we looking for? A representative or typical value in the data set, extent to which the data value is spread out, and the nature of distributions. Comparative dot plots, if you want to construct it, construct using the same numerical side, 2 or more dot plots. This is in case you want to compare 2 of them. Like on the next example, if you have 2 set of distribution and you want to compare. So like for this one, when you plot all these numbers, I see that this is like example that you have 2 different scenario here, and the second one is kind of symmetric shape. You see, when you plot all these points, you have a symmetric curve. This is the normal distributions, which everything is kind of symmetric compared to the mean or the value in the center. And this is the one that is kind of skewed to the left a little bit. So they're spread out all the way to the top and then to the right. So the dot plot would show you a distribution of the values, whether it's symmetric or it's skewed to the right or to the left. And so the first set of the homework is all about the dot plot. This is a blank one. I want to look at the blank one. And then the correct answer is this. So all I did was I tried to plot all these one by one, and I noticed the first one is the correct one. Because see here, like how do I know here I don't have any number less than 30, but this one has number less than 30, number less than 30. So these 2 are out because you don't have nothing less than 30. This one has 7 numbers between 45 and 50. And between 45 and 50, I have only 3 numbers, not 7 numbers. So that will leave to this one. So you gotta just check against the numbers that you have here, all these dot plots, to see which one is correct. Like this one, how do I know the answer is this? Because how many zeros do you have? You have 1, 2, 3, 4, 5. The only one that has 5 dots is this. So there are 5 zeros in this example. This one also has 5 zeros, but this one has 4 numbers after 25, like 26, 27. I don't have that many here. Okay, so that gives you that. So you need to just compare it. I leave a copy of this so you could actually see it yourself. Like this one. Again, I have 1, 2, 3, 4. So basically, section 3.1 is just all the dot plot. Now we go to 3.2. measure of the center. Now we are introducing mean. What is mean? The measure of center obtained by adding the value dividing by the number of value. Let's say you have two numbers, 4 and 6. How do you take the average of 4 and 6? 4 plus 6 divided by 2. So the formula to use for that, first of all, the symbol. In a stat, when you see this symbol is sum. X is the variable usually used to represent individual. N is number of data values. N, number of data value in population. So if you have the little n, that's the sample. Capital N is populations. So how do I calculate the mean? The mean is, this is a sample mean, this is a population mean. In the problem, you either have population or sample. In either case, you have the same formula. So if you just by mistake, you think that this population is not sample, you still come up with the same answer because they both have the same formula. It's just the letter that you use. This is a symbol we use for mean of population. This is a symbol we always use for sample mean or mean of the sample. Mean of the sample, mean of the population. So what we do is we add all the x's and divide by n. And you see that on the examples. What is the advantage and disadvantage of the mean? Advantage is relative reliable, means that the sample drawn from the same population do not vary as much. Disadvantage is very sensitive to every data value. One extreme value can affect it dramatically, is not the resistance. And I'll show you by the example. Outlier normally affect the mean, and then I'll tell you what outlier is. The other one is the median. The median value when the original data are arranged in order to increasing or decreasing. Often denoted by M, this is the symbol we use for the median, is not affected by extreme value. Extreme value is the outlier, is a resistant measure of the center. How do I find the median? Depend if the number of data is odd or is even. Okay. Now, this is a good example. Look. How many numbers do I have here? First, to find the median, first you got to put all the numbers in order from the smallest to the largest. Okay, so start from here, 0.42, 0.43, 73, 1.1, 5.4. See, the number keep increasing. If the number of values are even, you always have to take the average of the middle ones. But if the number is odd, then you could find a number exactly in the middle. For instance, let's think of the very simple example. Let's say you have these numbers 2, 5, 7, 10, and 14. How many numbers do we have? N is 5 numbers. What number is exactly in the middle? 7. So your median is 7. But what you have in the numbers like this, let's say 3, 7, 8, 10, 12, 18. How many numbers do I have? 6 numbers. The number of values is even. In that case, it's for you to find the number exactly in the middle, you have to take the average of these two. So the median is 8 plus 10 divided by 2 or 9. 9 is your median. So it just depends whether the number of values is even or is odd. Now this example shows you one of the major differences between mean and the median. So what we did here, we find price of 6 homes sold in 1 year in one of the area of the town. The price of the home that's sold was this: 380,000, 400,000, 410, 300,000, and there was a home which was sold in the same neighborhood for 850,000. We call this an outlier because it's completely deviate deviate from the other numbers. Now, when you want to calculate the mean, if you bring this into the calculations, how do I find the mean? Mean is just add all these numbers and divide by 1, 2, 3, 4, 5, 6. See? You add all the numbers, divide, you come up with 43,833. That's not really the actual value that you have to use if you want to put a house in the market. So for real estate, they try to use the median. Why? Because let's look at another example. In this example, price of the home that were sold was 290, 300, 380, 400, 400, and then all of a sudden 850. The outlier does not really impact the median, because for the median, we want to find a number exactly in the middle. A number exactly in the middle, since the number of value is even, is between these two or 390,000. See? So that's one of the reasons that we use the median in this case, because outlier could not impact the median that much, but the outlier definitely impact the mean, because mean add all the numbers and divide by how many do you have. So that's why if you want to put your house on the market and you want to know what price you should ask for your house, we should use median, not the mean, unless you don't have any outliers. Okay, means all the homes that were sold in that neighborhood with the same features, they all have numbers very close. Especially this is still true for the condos. All right, now we talk about the shape of the distribution. Mean and median cannot always be used to identify shape of the distribution. So when you have your distribution, you always see one of these three. If your curve is very symmetric, then mode and mean and median, they all would fall in the same place, which is in the center, and you have a symmetric shape. But if it's skewed to the right, it's skewed to the left, it's skewed to the right. See, in this case, mean and median are not the same points, they're different. So like the case like this is like, if you have something like that, when you have your bar graph, you see, is like that, and then like this. Then it's skewed, okay? It goes all the way up to the left and then kind of distribute to the right. All right. And here is, explain. What is a skew to the left? A skew to the right. Longer left tail is a skew to the left. And longer right tail is a skew to the right. Here explained about the symmetric. Distribution of data is symmetric if the left half of its histogram is roughly a mirror image of its right half. Next, we want to talk about standard deviation. A standard deviation measure deviation from the mean. Value close together have a small standard deviation, but value with a much more variation have a larger standard deviations. I want to show you how we calculate mean and a standard deviation. Look at this example. These numbers are given. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. There are two formulas that we normally use to calculate standard deviation. But for the mean, we have this formula. Mean is sum of x divided by n. How many x's do you have? You have 10 numbers. See, I listed like that. So the number that we give you in the problem, you list all the numbers here. And if you want to use this formula requires sum of x and sum of x2. So you should create a new column, which is x2, find sum of those, and sum of x is sum of these numbers. And you put it in the equation here. Now I want to also show you how to use the second formula. In fact, in our textbook, they talk about this formula rather than that. However, this one is easier to use. In this one, you need to find x minus x bar for each, and then raise it to power of 2. What is x bar? Is the sample mean, which we already calculated, 2188. So you need to come up with a new column, which is x minus sample mean, and then find it all together. So I'll show you that on the second page. Look, if I want to use the second formula, first I list all my numbers, 38, 37, 35. You list all those numbers here. Then the second column is mean, which means they remain the same. The third column is x minus mean. It means you take these numbers minus that, this minus that. And then the fourth column is you take the value here, like here is 15.12. When you raise it to power of 2, is giving you this. Then at the end, you are adding all this. You know, you could actually, if you understand how to use the calculator, make the life really easy for you. So here, for instance, if I want to use, let me see if I have that already. Yeah, see, what I did is this, look. To do that again for you, let's look. On the calculator, where you see the edit, enter, you have all these numbers. Now, I want to erase L2, L3, L4, and L5 and do it again for you, or L2, L3, L4. Okay, so I go to stat. Number 4 is clear list. I want everything on second. Okay. All the lists are here. You see that L1, L1, L2, L3, L4, L5. You see all this? So I want to delete everything on L2. Okay, hold on. Stat, clear list. So second, L2, comma, this is comma. L3, comma, L4, comma, and L5. Okay, all right, now let's look. Now I have stat. So what you do is first you input all those numbers here. You see 38, 37, you put all these numbers in the first column. Okay, now the formula has x minus x1. So I put everything on L1 here. Now I'm in L2, I put 21.88. So you go to, you just put 21.88, 21.88. Oh, we need one more. Okay. Now, what is L3? L3 is asking you to take this one and subtract L2 from it. So your L3, in fact, is asking you to take L1 minus L2. Take every number on L2 and subtract from L1, right? So to do that, you got to go all the way to the top. You got to go here to do that, not here. You go up, and then when you are there, enter. Now, you want L1 minus L2. Okay, L1 minus L2. It does give you all those numbers. Everything that you see here, like you see how we have 15.12 on the second one, they have 15.12 here. Now, next I need to find, I have to take x minus x and raise it to power of 2. In fact, that means L4 is L3 times L3 or L3 to power of 2, right? That means you have to take this one and raise it to power of 2. So you go to L4. L4 is L3 multiplied by another L3. L4 is L3 minus L3. Okay, so that would be the numbers that you have, L4. Now, in the formula, we need sum of x minus x. See here, let me show you. We need sum of x minus x to power of 2. Means we need to add everything on L4, because x minus x to power of 2, remember, it was L4. So we need to add all those numbers. We need to add all this. So there are two ways to do it. One is you could just go to stat, just show you, go to calculations, just enter. I'll do it again. Stat, you go to stat, and then go to calculations, enter, put L4 here, L4, and then calculate. Sum is 1159.296. That's the number that you have here, okay? So what you do is you put that one here, n is 10 minus 1. What you have under the radical, they call it variance. A standard deviation is a square root of the variance, and when you take a square root of the variance, that gives you the standard deviations, okay? So there are two ways to find the standard deviations. Again, one is using this formula, or they call it shortcut, which is this formula. To use this formula is easier because you just create the x, you put all the numbers are already x, right? The calculator would do the x2 for you and so on. So these problems here, these are the homework problems that are very similar. So let me see if I can write this for you so you could see it better. So you should be able to come up and work on this problem. They are very similar. They ask you to find the mean and the standard deviation. You could list all these numbers on your calculator and do that for you. So they're all very similar, the same. Okay. One thing you need to remember for the example that I show you. Okay. On this one, what if I ask you to find a median for these two? Okay. So you have all the numbers in L1. If you want to find median of the numbers in L1, or even if you want to find a mean, let's say you want to find a mean and a standard deviation and the median for these numbers. Go to Stat, go to Calculations. All my numbers are in L1. It calculates all of them. Look, it tells you the mean is 2188. A standard deviation, always take this SX, a standard deviation. Standard deviation is 11.34. And if you want a median, some problem they ask you for Q1 is right here. Median is Q2, they give you, and Q3. You have all these numbers here. So they're talking about the percentile. What is percentile? And how to find the percentile. Now, quartile, another type of problem that you have on the homework, they're asking about the quartiles. Okay. You have Q1, which is 25% of the data, Q2, which is also the median. Q2 is also the median. Q2 is 50% of the data. Q3 is third quartile, that is 75% of the data. So when we give you a bunch of numbers in the problem, we ask you to find Q1, Q2, or the median, and Q3. So what you do is you list all the data from the minimum, from the lowest to the highest. You have your minimum, you have your maximum numbers, and you divide the whole thing into 4 equal pieces. So divide rank is going to 4 equal parts. Now, I have 3 examples here to show you how to calculate that. Look, we give you all these numbers. We ask you to find Q3. We ask you to find 25% percentiles, or see, in this one, there are 24 numbers. So the formula is this for problem number 12. If we ask you to find Q3, or what number is 75%, you take 75 times, how many numbers do you have? 24 divided by 100. That would give you 18. If you come up with an even number, the norm is you should always take the average of 18 and 19. Why? Because remember, Q2 is the median, and the median, if you have even numbers, you have 24. If you want to find the middle one, you have to take the average of 18 and 19. So 18 and 19 is these two. The same thing for problem number 13. They want to find the percentile of 25, but you have 36 numbers. So when you do the calculation, you come up with 18. 18 means you start from the beginning and count which number is number 18. But then you have to take 18 and 19, take the average. That is your Q2, which is the median. I'm sorry, this for that one, and for 13 is 9, so you take the average of 9, 10. And this one, there are 36 numbers. How do I find Q2 or 50%? You take 18 and 19. I'll put another example here. If you have 5 numbers and we ask you to find median or Q2, what is the Q2 here? It's 5, because it's exactly in the middle. But if the number of values are even, like here, 1, 2, 3, 4, 5, 6, median is you have to take the average of these two. Okay? That's what happened. All these examples, look, there are 24 numbers, there are 36 numbers, there are 36 numbers. So when you find with the whole number here, you always have to take that number and one after to take the average. Okay. All right. We have another definition that we are using later on for, they call it interquartile range, or IQR. IQR is Q3 minus Q1. There are 5 number summary that we are using the next set of the homework for box plot. Box plot is 5 numbers. Minimum number, maximum number, Q1, Q2, Q3. And you understand it when you look at the examples. What is box plot? Box plot or box and whisker diagram is a graph of data set that consists of the line extending from the minimum value to the maximum value, and the box with the line drawn at the first quarter, Q1, Q2, and Q3. That's what the box plot is. So when we ask you to graph the box plot, when we give you a bunch of numbers, you have to find your minimum number and the maximum numbers. Then you need to find the Q1, Q2, and Q3, and then you draw this box. This is a box plot. So there are 5 numbers: minimum, maximum, Q1, Q2, Q3. Another one. Normal distribution, height from the simple random sample of women. This is one of the examples that you have the minimum, you have the maximum, Q1, Q2, Q3. This is another one. This one, box plot shows distributions. Like this one, you see that median and Q1 and Q3 are kind of close to the minimum. So this is like the one that is the skew. It's like it's going up and then it's spread like that. Box plot is a good representative of distribution. Now, like this example, since the box plot or the median is exactly in the middle, you have a good symmetric shape. But this one, since most of the numbers are kind of closer to the left, close to the left, you have a skew to the left and tail is to the right. Here, I'll show you later on how to use the calculator to graph box plot. All right, let's look at the example. We have these numbers. The following are amount of time spent on hygienic and grooming in the morning by survey respondent. These numbers are given. We want to graph a box plot for it. We need to find Q1, we need to find Q2 and Q3. Q1 is 25% of the data. How many numbers do we have? 1, 2, 3, 4. There are 25, 20, there are 18 numbers here. So 25% of 18 is 4.5. If you have a decimal, you round it up to 5. Okay. If it's a decimal and you round it to 5, then you go and read which one is number 5. 1, 2, 3, 4, 5. So that would be your Q1. 50% or median. If your number is even number, or I'm sorry, if your number is whole number, you always have to take the average. So the rule is this. When you do the calculations, if you come up with a decimal number, you could always round it up, and then you just go and see which number is in location of 5. 1, 2, 3, 4, 5. But if the number is the whole number, don't say the number, which position has now. Don't say 1, 2, 3, 4, 5, 6, 7, 8, 9. No. In this case, both are 18, but normally you should, if the number is whole, you should take the average of 9 and 10. Like this one. The number is the decimal, you round it up to 14, so you start counting to see which number is 14 is 32. So this is Q1, Q2, Q3. What number is the minimum? Since I have everything in order, is 4 and 63. So you put 4, 63, Q1, Q2, Q3. So what I did was I already put this in the calculator. You see all those numbers? 4, 6, 7, 9. You put everything in L1. So I use a different calculator so we don't waste that much time inputting all this. Okay, so you see all these numbers are here. The last one was 63, right? See? The last one is 63. All right. So now, when you input all the numbers, I put everything in L1. You go to stat again. Go to calculations. The very first one variance stat, enter. Now, I have all my numbers in L1. So you go to the second L1. Okay? Now, what it gave you is this. It tells you that there are 18 numbers. They tell you the minimum is 4. Q1 is 14. Q2 or median is 18. Q3 is 32. Maximum is 63. See, it gives you all 5 numbers, okay? That's how to find it. Now, you want to graph it, right? Okay. So here I have it. Stat, edit L1. You already have all this. You have everything in L1. Go to stat again. Calculations. Well, no, we did this one. Okay. Let's look at this one. This is the previous page. You have everything in L1 already, right? Go to Y, which is, which one is it? It's this. Y equal. I don't know if you could see it or not. It's Y. But the second. So second Y. You want to make sure that the is off. So the very first time when you use it is like this. Okay. Look. So you go to the second. I do it again because it wasn't off. You go to second, and then behind Y is a stat plot. Stat plot that we are going to use it a lot in statistics. So you go second stat. Okay. You want to make sure the first one is on. You need one of these. So let's say the first one I want to be on is off right now. Enter. Change it to on. Now, which one of these looks like a box plot? It looks like this one is a box plot, right? So make sure the first one is on. Okay. Enter. You have everything in L1, correct? Okay. So far. Now it said go and plot or graph here. You want to graph it now. If it's not clear, look, when you put a graph and it's not clear, go to zoom. It said zoom stat. Go to zoom stat. And enter. Okay, let's try it again. Make sure that we have everything there. The first one, it should be on. I don't know why. You have to be on. Let's put it on first. Enter. Okay, so now let's go graph it. And that gives you. So if you already have information on L1, if you want to graph your box plot, that's how to do it. You start from here. You press the second, and then what? Why? Because the stat plot is behind this. And when you do that, you want to make sure the first one is on. See, mine was off before. You want to make sure it's on. When you click it, make sure it's on, and see, make sure you are on this one. Okay, all right. So that gives you how to do this box plot. You get a better graph when you use the calculus. Next is the outliers and modified box plot. You know, one of the things that would impact the box plot is the outliers. Outliers is a value that lies very far from the vast majority of the other values in the data set. And here explain the outlier can have a dramatic effect on the mean, can have effect on the standard deviation, on everything. So you can read that. How do we collect it? I'm sorry, how do we modify the what box? Let me correct this one here. All right. I'll show you how to modify it. But again, I'll show you by the examples. All right, let's look at this example. Sorry, just a second. Let me see if I can fix this so we all see it better. Okay. These numbers are given, all right? So notice here, there is one number that is really way from the other ones. See, 2 and then 51. See, this number is definitely outliers, okay? But how do we find out the outlier? This is simple examples. First, you need to put all the numbers in order from the lowest to the highest. Then you need to find your Q1, Q2, Q3 small. You find that through the calculator, right? I'll show you already how to do it. So then you need this Q1, they call it lower quartiles. Q3, they call it upper quartiles. You have to find your IQR. What is IQR? IQR is Q3 minus Q1. So you take Q3 and Q1 and find the difference. Then you need to multiply 1.5 by that number. 1.5 times that is 16.5. Now you need to find your Q1 minus 1.5 IQR and Q3 plus 1.5. These two will determine the boundary. That means if any of these numbers are beyond this, lower or greater than these, are outliers. So what these two does, it gives you the boundary or end point on each side. So if any number fall below this or greater than that, is the outliers. So when you graph your box plot, you see that 2 is the outlier. So you mentioned that is outliers. Okay. So again, to find the outliers, first you have to find Q1 minus 1.5 IQR and Q3 plus 1.5 IQR. IQR is these numbers. Find 1.5 times that, then bring it and subtract from Q1, add to Q3 to find your boundary. These are the examples that you want to follow. And where's the solution of these? It's here. See, I show you how to find Q1, Q2, Q3. This is another examples. Construct the box plot for these numbers. So you find Q1, Q2, Q3. You could either do it this way, hand calculations, or I think it's easy if you just input all the numbers and the way I show you, find Q1, Q2, Q3. Okay? Then find 1.5 times IQR, Q1 minus this Q. See, when you find a boundary here, there are two numbers outside of this boundary. One is 3, one is 34. What are your outliers here? 3 and 34. That's how to find the outliers when you have a bunch of numbers. and you want to draw your box plot. They call it modified box plot. Means if you have a box plot and there are a few numbers that are outliers, you get to remove those to find a better box plot. So these are some examples that you could follow. And then we go to, I'll put a solution for you so you could check practice. These are similar to your homework assignment. I don't want to go through these because it's a lot of time. The last subject is, one of the things is empirical rule. Empirical rules, they have done calculation and they came up with this rule that 68% of all the value fall within one standard deviation, 95 within two standard deviation, and 99.7 is 3. So this is empirical rule. They claim that when you have all the data, 68% is always mean plus 1 standard deviation. 95% is mean plus 2 standard deviation or minus 2 standard deviation, and 95% is beyond that. Okay, so this is for 68% when it's 1 standard deviation. And if you go to 3 standard deviations, it's almost 99.7% are within 3 standard deviations. So we need to use this empirical rule to do some of the homework problems here. Then another one is they call it z-score. Z-score, this is a formula that we use for z-score. In order to find the z, you need to have your sample mean and standard deviation of sample, or if you're dealing with the population, is mean of population and standard deviation of population. Now here, sometimes I give you a number in the problem, say, is this usual or not? If we do have to calculate the z. If the z is between -2 and +2, then it's an ordinary value. If the number is beyond 2 or below 2, below -2, then is unusual value. Okay, so that's a z-score. Now we go to the last one. This is a good example that I'll show you here. When you are comparing 2 items from 2 different populations, you cannot compare it unless you bring both to the same scale. Like here, height of Lyndon Johnson was 75 inch. It was the tallest president of past century. 85 inch was Shaquille, tallest basketball player. And we want to know which one is relatively taller. They are from 2 different groups. So if you want to compare them, you have to use the Z formula in order to bring them to the same scale. When you bring them to the same scale, Johnson is 1.67 and Shaquille is 1.52. So that means Lyndon Johnson is relatively taller than Shaquille. However, here, look, here we said Lyndon Johnson was 75 inch and Shaquille was 85 inch. But that doesn't mean that Shaquille is taller than Lincoln. Why? Because they are in different scales. So if you want to know relatively which one is taller, you have to calculate the Z for each, and then you could compare. That's where we use the Z value. This is another example. Let's say you have 2 tests. You want to comparing the SAT test and ACT test. So we give you a standard deviation and mean of each. And these 2 numbers that you're going to compare are 1490, somebody get 1490 in SAT and 17 on SAT. How do you compare that? First, you have to use the Z. So according to Z, minus 0.09 is greater than 0.85 on the number line. See that? So this one is relatively taller than that. All right, so these are, I'll put another example here for one of the homework problems. The first test, mean and standard deviation given, x1 is 675. The second test, 40, you do the comparison. Now, this is the problem number 2 which is this one. So if you read these problems, this is the solutions. And we use the empirical rule. Empirical rule is saying that you have to find mean plus 1 standard deviations, mean plus 2 standard deviation, mean plus 3 standard deviation. If your mean is 1 plus standard deviations, is 67.8, or if it's 2, it's 0.95 and 0.997. See, I'll show you here. See, empirical rule, I'll put that numbers here. Empirical rule is claim that 68% of data fall between sample mean minus 1 standard deviation, sample mean plus 1 standard, or in our calculation is, for that example, is 21 to 37. Second calculation showed that they have 25 and 41. That is 95% of the data fall between these two. And if you have plus or minus 3 standard deviation, is 21 and 45 for that problem, which is 99.7. Okay, so you could use all of this to do the problems on chapter 3.